Good morning, friends. Today we'll cover chapter 21, which is using object input filter interface. So this is a functional interface. So deserialization of untrusted data can lead to vulnerabilities that allow an attacker to execute arbitrary code. The readObject method in ObjectInputStream, which we use to deserialize any type of object, will construct any type of serializable object that can be found on the class path before passing it back to the caller. So what it means is that if you look at this diagram that we have been referring before as well, let's suppose we have got an object and then we call object output stream dot write object. So it will convert it into stream of bytes, and we can store it in various formats, whether we can store it in a file, database, memory, and network. And during the deserialization process, we call ObjectInputStream dot readObject method, and then use this stream of bytes stored in this file or network or wherever, and construct this object based on that. But suppose what happens that this stream of bytes, which has been stored in this file, database, memory, or network anywhere, it has been hacked, and then that stream of bytes has been replaced with any malicious code. It can be a virus or it can be a malware, whatever. The attacker has corrupted this stream of bytes, and during the process of deserialization, whenever we deserialize this back to this object, only then we can have a choice for any type of validation. For example, we have got object input validation interface where we can validate this object, but we have already constructed this object. And while construction of this object, there can be this malicious code which has been put into the stream of bytes that has already been executed and affected our security system. So having this validation on this final object will not help us to save from this attack, because the stream of bytes has already been executed. To understand this better, let's look at this very simple code of deserialization, where we are reading the state of the object. We are reading the objects from a file. Suppose it's a file, and we have this object input stream on this file input stream on this file temp, and then we simply want to read object of string and a date. So as shown in the above code, the application code invokes the readObject method of an object input stream to read an object from a stream. So we already know this. And the stream may include any objects, not just the anticipated string and date objects. Now, if the data read is not a string and date object, we know that the cast operation, the cast that we are applying here, that string and date, will result in a class cast exception or class not find exception, if no definition of the class with the specified name could be found. But unfortunately, by the time the type checking happens, platform code has already executed significant logic that could easily result in a successful exploit. During this process, we have already done a lot of things, and this is the surface of attack for any attacker if it has manipulated by the stream of bytes. So this stream of bytes, which is already being affected, this can execute any type of virus or malware or any type of security hack, which can actually infect our whole security system. And this has actually happened in 2016 in November, when the Muni system, which is the transport system in San Francisco, it was affected by the very old Java vulnerability, which is actually the deserialization process attack that we just discussed. So what happened is that if you go in this article, so that attacker actually affected this, and what happened is he actually exposed this deserialization attack that we just discussed. It actually hacked that system where the stream of bytes were serialized, and then it actually he was able to hack the system, and for 2 days the system was showing this, that you're hacked and all data encrypted and all, and it was entering a key to get some Bitcoin or something. So this is what we are talking about. So this has actually happened, and this deserialization attack is like very very dangerous, and it has got a lot of security holes. So thus, if a rogue process sends us very large arrays or instances of classes, that could be considered dangerous. So means that here the stream of bytes, it can be a large number of arrays, many classes which has been hacked and compromised, which contains the main purpose of this hacker is that supposed to shut down the system, not do anything, but just shut down the system by including a large number of arrays that the whole the JVM memory would be out of memory because of that huge sizes of arrays which has been included in this stream of bytes. So we could perhaps check the generated instance. So as we mentioned that once the object is created, only then we have got the validation process via ObjectInputValidation interface. But at that point, the instance has already been constructed, right? We might already have run out of memory on the server or been hacked in some way. It also means that if an attacker is able to put malicious data into the serialized object, this will cause serious security issues to the system. Now, to prevent all this Java deserialization vulnerabilities, an application has to restrict a set of classes which may be deserialized. So one way, I mean, we can think that we can just ensure that that the stream of bytes that we are deserializing back, that only should be a set of classes that we know. It cannot be outside that set of classes that should be serialized. One is that way. Another way we can check is that we can check the size of the bytes. If the size is like very huge number, it means that it has been compromised and it has been hacked, and we can have a check on that. Similarly, there are other type of like filters we can do before we actually construct the object. So what we mean is that we should have something here in between. When we are constructing this object from the stream of bytes, we can have multiple checks here. Like we can check the class name that we are serializing. We can check the size of the bytes, or we can check that how many object references it has. It can not have like multiple object references, like thousands and like many large number, which means that the stream of bytes has been compromised. So for all these reasons, and to prevent all these type of deserialization attacks, ObjectInputFilter interface, which is a functional interface, it was introduced in Java 9. So Java 9 came in around September 2017. And it has got a method. Because it's a functional interface, it has got only one method, which is check input. And it takes a filter info, the reference of it, as a method parameter. And this filter info provides the following filters choices to check. For example, as I mentioned that we can check that the serial class, which means that the class of an object being deserialized. So we can have a check by using the serial class, using this filter info argument to this check input method, whether the class that we are serializing, that is what we want. It cannot be anything outside of that. For example, my Java Pujo class is say market data, and in market data, I only expect that when we deserialize it back, the serial class would be the market data, not any other object. If there's any other object or for a class, we should simply discard that. That is the first check. And we can also have this array length, the number of array elements. If we have got any array elements, or even for the Java Pujo object, as we have learned in the previous chapters, that we can serialize the whole set of arrays for a class. And so we can also check that what is the size of that array. If this array is like not expected to be a very huge number, it means that it should be correct. The depth of an object graph at that point, because as we know that one Java Pujo class can have reference to many other objects, and we can have an object graph. But at least by the time of serializing this class, we know that how much deep it can go. References, the current number of object references, it can have 1, 2, 3, many multiple number of object references. But we know that it has to be a certain number, because we know that what we have serialized before. Similarly, the stream of bytes, that stream bytes is that current number of bytes consumed. So all these checks can be done at this point before this object is constructed, and which can save us from all this type of deserialization attacks. Now, once we have all these checks, all this in the filter info, the method returns either status.undecided, allowed, or rejected. So if any of the checks, we got the information, and so we can actually return that whether we want to continue the deserialization process or not. If we don't want to continue, we can simply return rejected, and the process will shut down here. It will not construct the object here. And only if it is allowed, only then it will proceed further to deserialize this object. So we should use allowed if we want the object to be accepted, or we should mark them as rejected if we want this to be rejected. Undecided means that we allow later filters to override, but currently it is undecided, not allowed and not rejected, which means that suppose we are just checking the serial class and we found that class is good. And now we further want to check whether the stream bytes, the number of bytes consumed is good enough. So at this point, we can just mark it as undecided because we are still checking we are still doing other checks to confirm whether our deserialization process is good or not so far. And this is a default behavior as well. Now, we can implement serialization filters in two ways. To having this check input filter, there are two ways possible. We can just define the custom filters by implementing check input filter info method of object input filter interface, as we just discussed. And we can also provide a pattern-based filters which can accept or reject specific classes, packages, or modules. So a class that matches a pattern that is preceded by not sign is rejected, and a class that matches a pattern without not is accepted. So this is all the theory that we have covered so far. So now let's write some unit tests to understand this better, where we'll actually implement both of these two ways that we just discussed. So see you all in the next video.